So I will just tell why we use correlation. So we know that we are doing a data mining here, right? And so when we take data from different databases, so what happens here? When we take data from, sometimes we get the redundant attributes. So let's say if I take an example, like if you take annual revenue, okay. So now annual revenue, instead of taking directly from the database, you can derive it from other attributes, right? So in order to find out what attributes are related to annual revenue or which attributes we can use, we need to find the correlation between the attributes. So this can help us in removing the redundancies, in reducing the redundancies in the data. So if two attributes are given to you, data for the two attributes is given to you, you can find how strongly they are related to each other. That means how strongly one attribute implies the other attribute based on the data that is available to you. So that's where we use this correlation to find out how closely the two attributes are related to each other. Okay, so in order to find that correlation, we use a formula called correlation coefficient, or called as Pearson products movement coefficient. Okay, so firstly I will just read through this formula, and then I will take a problem, and then we will relate the problem with this formula, so that we will understand how we have to use this formula. Okay, let's see. So the formula for correlation coefficient is, you are finding a correlation between A and B. A is nothing but your one type of attribute, and B is another type of attribute. So a set of values will be given for A and B. The formula is summation of I is equal to 1 to n AI minus, I will explain each term, AI minus A bar into BI minus B bar by n into sigma A into sigma B. Now what is this? A bar here, capital A bar, is nothing but the mean value of all those attributes that is given to you, values of the attributes that is given to you. So mean of A, that means attributes of type A, and B is nothing but mean of B. B bar is nothing but mean value of B, values of B. And sigma A is nothing but the standard deviation. Okay, we will again see actually I should have taken mean and standard deviation first, but this is how I prepared, so same way I will go. So just see that standard deviation formula is A minus A bar whole square by n, and standard deviation B will be B minus B bar whole square by n. This is a summation here. So I mean, by seeing this formula, it may not be very clear. We'll take a problem. Okay, now if you see this problem, there are two attributes A and B, and for A and B the data is given, the values are given, and here n is 10. N is 10 means number of tuples are 10, number of values are 10 here. So you make this table, it will be very easy to solve this problem with this table. Okay, in this table you just first write this formula, and then as per this formula make this table. First you write down A, all the A values, all the B values. Okay, next in this formula, if you see, what do we need? We need A bar. A bar is nothing but the mean value of A. Mean value of A. That means what you have to do, you have to do the summation of all the A. That means you have to add up all the A values. You have to add up all the B values. A bar will be summation of values of A divided by total number of tuples that we have. Okay, so that will be your A bar value. So you find out A bar and B bar. Now we have got A bar and B bar. Next is your AI minus A bar. That means for each value of A, you subtract the mean value from each value. That means you will find 2 minus 5 minus 3, 3 minus 5 minus 2, something like this. Okay, similarly you find B minus B bar, and then you can find then what we need for finding standard deviation, we need A minus A bar whole square. So you again write A minus A bar whole square. So you square all these values. So we'll get a minus a bar whole square. Okay. Similarly, you find b minus b bar whole square. And then you have a minus a bar into b minus b bar. That's what we need here, right? In the first, in the numerator, a minus a bar into b minus b bar. So find a minus a bar into b minus b bar. Now, for all which all values we need summation. We need summation for a minus a bar whole square, b minus b bar whole square, and this one. So what you do, add up all those columns values that you have found out. Okay. Now, first we will find standard deviation. So standard deviation formula is square root of sigma a minus a bar whole square by n. So sigma a minus a bar, summation of a minus a bar whole square is this, right? So just write inside the square root that value that you have obtained here, 66, and n is your 10. So just find out standard deviation of A, standard deviation of B. Okay. So we have got standard deviation of A and standard deviation of B. So now substitute all those value in this formula. So summation of A minus A bar into B minus B bar we have got as minus 86. Substitute here, substitute your n value, substitute the standard deviation of A, standard deviation of B, and then you will receive the value RAB, that is correlation between A and B, as 0.96. Now what this 0.96 indicates that A and B are, we have received minus 0.96. So minus means it indicates that they are negatively correlated. Means they are not correlated to each other. Okay. Suppose this value is 0, then it indicates that they are independent. There is no relationship between A and B. And if it is greater than 0, then that means they are positively correlated. So when we will say that they are, very highly correlated, when this value is 1, when it is equal to 1, that means they are highly correlated. So in order for the two attributes to be correlated, this value should be greater than 0. Okay. If it is 0, they are not related at all. They are independent. If it is negative, then it is like negatively correlated. That means if one will increase, the other will decrease. Something like that. Okay. I'll just check if any messages people are sending. Okay, I will not be checking messages again, every time. What we will do is, after I complete some set of numericals, I will put everybody on unmute. I will just remove that restriction. And then you can ask, okay, for 2 minutes or 3 minutes, we will take the questions. Okay. So this was all about correlation. Okay. Next is covariance. I think correlation is clear. It is pretty straightforward. Okay. Next, we will go for covariance. Okay. Now, what is covariance? Why we use covariance? Covariance is used to measure the variables that have different unit of measurement. That means, suppose any two, let's take an example of exercise and blood sugar. So exercise is measured like how many hours you are doing the exercise. Based on that, what is your blood sugar value? So both the variables, both the attributes have different units of measurement, right? So if you want to find the correlation, co-relationship between, or how much they are related to each other, how they are related, we use covariance. Okay. So covariance can tell us the direction, like in which direction these two are going, whether they are increasing direction or decreasing direction, but they will not tell us the degree, okay, to which these variables are moving together. They will not give any particular value, but they will just tell us whether they are related in a positive direction or a negative direction. So formula for covariance is just same formula like correlation coefficient only. In denominator, we do not have that standard deviation, sigma A and sigma B. That's it. That is the difference. And then there you can derive the relation between covariance and correlation, because this is the same formula, right? So in place of this whole thing, in correlation formula, you can replace with covariance. So that means your correlation and covariance are related with this formula. So let's see a problem. So again, I have taken some, suppose two stocks. Suppose let's take two stocks, A and B, and their values in 1 week. That these are so, and we have given with the statement that stocks are affected by same industry trends. Okay, based on the industry trends, both the stocks are affected similarly. So we need to predict, will their prices rise or fall together. I mean, if one stock is suppose increasing, their price is increasing, will the other stock price also will increase, or will they fall together? So in that case, we are using covariance. So covariance formula, as we have seen, a minus a bar into b minus b bar. So similarly, again, you can put a table and where you can write your a minus a bar and b minus b bar, and then you have to find the summation. So multiply this a minus a bar into b minus b bar and find the summation, and then you can substitute in this formula. You might be seeing here I have written something different. So this is another formula, that is dot product of a dot b. So just don't go with this one. We will use this formula only, okay? Because let's be consistent. So now whatever value we have received for covariance, it is 3.96. So when covariance is greater than 0, it indicates that two variables will move in the same direction. Okay, that means if A will increase, B will also increase. So they will rise together. But if it is less than 0, that means they will move in the reverse direction. That means if one variable is increasing, other will tend to decrease. So this is covariance between two variables. Okay. So this was about covariance. Next is correlation analysis for nominal data. So I think people are aware what is nominal data, what is numerical data. So the this upper two formulas that we have seen, that was for numerical data, and correlation analysis using chi-square test is done for nominal data. Okay. So the formula is summation of observed minus expected whole square by expected. Just with this formula, we don't understand anything. What is observed, what is expected, right? So let's see how do we find it. Okay, let me take this problem. So in this problem, we are going to find the correlation between two variables, qualification A and marital status B. And we will see that whether both of them are related to each other. Related means whether your marital status depends on qualification or not. Okay, something like that. So these two are a nominal attributes. Okay, these are not like numeric. You cannot count qualification in numeric, right? Marital. So here, if you see, we have qualification. So what you have to do first, you draw a table, okay, and then in that table, so we have to calculate how marital status is related to qualification. So you write qualification row wise, qualification column wise, and then this marital status in this y-axis, and the qualification in this something like x-axis. Okay, and basically this table will be given as it is. I think if they have given any problem on this one, the table will be given as it is. That's what I have seen in many problems. Okay, so that will not be a confusion where you have to write what, and then these are the values. So this part is given, this total part will not be given. So first step to find the chi-square, you have to write the total. Total is nothing but total of this particular row, this particular row, this particular row, this particular row. And in this column wise also, this is a total of this, total of this, total of this, total of this, total of this. And this 300 is nothing but total of all these 4 rows. And similarly, if you do the total of all these 4 values, 39, 90, that will also be 300 only. Okay. Okay, next you have to prepare this contingency table. In this table, you have to find the expected values. So as per the formula, we need to find observed minus expected by expected, right? Observed is nothing but the values that is given to us. Okay, and expected is what we're supposed to find to fill in this formula. So next, after doing this total, we will go to another table. We'll prepare this table called as contingency table, and here we will find out expected values. Now, how do these expected values we have to find? Okay. Now, for first cell, this particular cell, how the value will be found out is, now the total of this particular row. So this cell we have to find, right? The cell where we have value 18. So corresponding total in this row 90 into corresponding total in this column 39 divided by total value 300. So for this cell, that means where middle school and never married is 18, for that the expected value will be 90 into 39 divided by 300. Similarly, if I go for 36, cell number 36, for this one, you have to find expected value. So corresponding row total 90 into corresponding column total into 90 divided by total value 300. Similarly, if you go below, so for this cell where you have 12, where you have value 12, if you have to find the expected values for this cell, that is nothing but corresponding total of this row into corresponding total in this column divided by 300. Okay. So this is how you have to find all the expected values and tabulate here. So once this is done, again next third table. In third table, what you have to do, we are going to do the final calculation. So in this, what you do, write all your observed values. Write all your expected values. That means observed values is 18, 36, 21, 9, 6, 12, 36, 45, everything. Just each cell you just tabulate here, okay? One by one. And corresponding expected values also you write in the second column. Next, what is the formula? Observed minus expected whole square by expected, right? So first we need to find observed minus expected. So observed values minus expected values we have tabulated. So you find observed minus expected whole square, then divided by expected value. Just tabulate everything, okay? If you do this way, right, there will not be any confusion. You just go by the formula, tabulate every step, okay? Now what we have to do? We have to do summation. The formula has, now we have found out all this, observed minus expected whole square by expected for each and every cell we have found out. Now we have to do the summation. So you know what you have to do, you have to add up all these values, okay? You have to add up all, I have not written here, just you have to add up all these values. What is the chi-square? So once you add up all this, chi-square value you get some 23.57. So now this is your calculated value. Then what you have to do, you have to find the tabular value. So there is one table, this is a chi-square table. Now what you have to do, you have to find the tabular value of chi-square. So how do you find the tabular value? You have to first calculate degree of freedom. How do you find degree of freedom? So how many columns we have here? Where is that? How many columns we have? 1, 2, 3, 4, 5. And how many rows? 1, 2, 3, 4. That means column minus 1 into rows minus 1. So this is your degree of freedom. That value is 12. Okay. So if you go to table and then you have to find against degree of freedom 12, you have to find the value. See, if you see, there is a value 21.026 with a significance of 0.05. Okay, we have to take this value. See, if suppose in this row there is all the values are less than that, I mean all the values are bigger than this one. Where is it? All the values are bigger than this value, 23 point whatever we have got. That means your calculated value is less than the tabular value. But if you see in the table against your degree of freedom 12, you see that you have a value which is less. At what significance? At 0.05 significance. Okay, you have got some value which is less, but rest all values are more than that. So just ignore that. Okay, and then that will be your tabular value. That will be your chi-square tabular value. Now you compare your calculated value and tabular value. So your calculated value is greater than your chi-square tabular value. Hence, qualification and marital status has a significant relationship. Okay. In case if in your table against your 12, against your degree of freedom 12, all the values are more than that, more than this particular value that you have received, that you have calculated, then that means your calculated value will be less than your tabular value, and qualification and marital status will not have any significant relationship. But here in this case, our calculated value has more than tabular value, so that means they both are has a significant relation. Okay, so this was about chi-square test for nominal data. Okay, next is normalization. Okay, now what is normalization? Why do we go for normalization? See, you know that measurement unit that we use for attributes can affect our data analysis. For example, if you change the measurement units from meters to inches, or from height, from kg to pounds for weight, and from meters to inches for height, then what happens? It will lead to different results. That means if you are using meters and kilogram for any two different attributes, you will get different results. And if you are using inches or pounds, then you will get different results. So in order to avoid this dependency on the choice of measurement units, we have to normalize our data to a standard limit. Okay, so that means we will transform our data that will fall in a smaller or a common range. That means suppose you have in a set of attributes, you have a height and you have a weight, you will normalize it to some common range limit, so that the measurement units that are different for the two attributes will not impact your output. Okay, so how do you normalize? The formula for normalization is V1 minus min of A by max of A minus min of A into new max of A minus new min of A plus new min of A. I'll explain this. So here V1 dash is nothing but your normalized value. You want to normalize your V1, okay? And minimum of A is nothing but the minimum value in the set of values that is given to you. And max of A is the maximum value. New max of A is nothing but the new maximum limit you want to normalize, minus new minimum is the, it will be very clear when we will see the problem. Okay, just first remember this formula. Then for normalization, we have three formulas. One is min max, Z score, normalization by decimal scaling. Okay, first we'll see all the three formulas, then we'll see problems together. For Z-score normalization, this is a formula. So V is nothing but the value that you want to normalize. Mu A is nothing but the mean of A, the set of values of A that are given to you, mean of that. And sigma is nothing but a standard deviation. Normalization by decimal scaling. Decimal scaling means you will be moving some decimals. You will be moving the value to some decimals. Now, formula is V dash is equal to V by 10 power j. V is nothing but the value that you want to normalize, and 10 power j. What is this j? J will be max of V dash, which is less than 1. That means 99 and 9. Suppose these two are the values for your V. Okay. Now, what is the which has the maximum number of digits? 99. So how many digits? 2. So your j value will become 2. Suppose here we have 999, one more value, then your j value would have become 3. Okay, let's see the problem. Okay, Just a minute, I see some messages coming. Okay, let's see income range $12,000 to $98,000. We want to normalize it to between 0, 1. So original income range is $12,000 to $98,000. That means what is your minimum value here now? Minimum value would be $12,000. That is original minimum value. And original maximum value $98,000. You want to normalize it to between 0 and 1. Okay, now what value they want us to find out the normalized value. For what value? For $73,600. Okay, $73,600 will be mapped to which value between 0 and 1 they are asking. So what is your new minimum? New minimum is 0. What is your new maximum? New maximum is 1. Okay. So now as per the formula, our formula is VI dash. VI dash means the normalized value that you will get. V is nothing but the value that you want to normalize. So we are normalizing here 73,600. Okay. V minus, what was the formula? Min of A. What is the min value here? What is the min value? Original min value 12,000 by max of A minus min of A. So what is the max value? 98,000 and minimum value 12,000 into new max of A minus new min of A. What is the new max of A value? 1. That means new maximum range 1. New maximum minimum value 0 plus new min of A. So we have substituted and we have received 0.76, which is nothing but a normalized value of $73,600, and it falls between 0 and 1. So that's what we want to do, right? We want to normalize our values to fall between 0 and 1. So this is nothing but min-max normalization. Next is Z-score normalization. So mu is just a very straightforward. Okay, mu is given, sigma is given. So you want to normalize your again salary 73,600. Just substitute in the formula. Okay, this is very simple. Now normalization by decimal scaling. So here I told we are going to move the decimal point of values. That means you are going to move attribute A value to some decimal points. Okay. Now what is J here? Here 99 is the, I mean, if you see here, the number of digits in 99 is highest here in this set. Okay. So how many digits? 2. So your J value will become 2. That means you have to decimal scale by 99. So now you have to normalize this value, right? This whole set. So you divide 99 by 100 and 9 also by 100. Okay. The value that you receive will be your normalized value. Another set is given. Another set 273, 4866. Now in this 2 set, which is having highest number of digits, 4866. Number of digits is 4. That means 10 power 4. Okay. So formula is V by 10 power J. That means V is nothing but here 273 divided by 10 power J, 10 power 4. And then you receive the normalized value. Okay, we will take the any questions, if any, within 2 minutes till here, and then we will go with the next topic. Okay, so I will just I will, yeah, one by one. If anyone has any question, please.
Yeah, hi, Anu. This is Raja. See, actually, the minimization, maximization, right? You have mentioned that the minimum, the range is 0, 1, right? That is the minimum is 0 and maximum is 1. In the question paper itself, I saw that they have given 50 and 70. So we have to take the minimum and the maximum is 50, 70 respectively, right?
Yes, yes, okay. Exactly.
Okay.
Yeah.
Okay, thank you.
Can we do these things in the Excel, Anu, when in the exam?
Excel, sorry, Kareem, I am not sure. I mean, I don't
I
think
think yes.
we will need any Excel. Yeah.
I think yes, we can do in Excel. That's not a problem in the exam also, and it is quite convenient if you are good in Excel.
If you're keeping a Excel sheet ready for all these formulas, that can be convenient.
Yes,
But only thing is whether you can use it without getting caught is the main thing. Yeah.
I think we can use it, right? No problem. Yeah.
Okay. Yeah.
So can we write direct answer from the Excel if in the question we have to calculate standard deviation?
But I think I'll suggest everybody not to write direct answers. Please write formula, because if you see the previous paper key, it is like one mark for formula, 1 mark for calculation. So I will suggest not to go for direct shortcuts. Okay.
Okay, thank you.
Anu,
Okay.
for different normalization methods, the 3 normalizations that you taught, so which to use when, that how will we come to know?
I think I mean, these are different. So there is no, like for correlation and covariance, we have some constraints, right? For correlation, you have to use for this kind of data, and covariance for. But for normalization, I did not see. Those are the 3 normalization, and I think most of the time they have asked only min-max normalization, not the other 2.
Okay.
And
I
they
would
have
like to
mentioned.
say something like min-max normalization is nothing but you're having a data which is spanning around a larger range. Then you want to scale it to some lesser range. Suppose you're having a data which is spanning from thousands, but just to come around in the same domain, you want to bring the data into the same domain. Then you're scaling it to a similar line. It's basically line fitting only. This formula is nothing but you're fitting it to the same line with the different with the same what you can call it slope and different x and y's. In that way only you are just scaling that line. So in that way you're bringing the data from a higher side of the one quadrant to the lower side of a quadrant. And then it comes a z score. It basically depends what you want to do with your data. In that way you're going to use it. Basically they will be telling that in the question itself which formula do you want to use, but more or the less most of the times you'll be using min max only.
Okay. Thank you, Ashok.
Another thing I wanted to ask Anu, like we are doing right here, like up till now we have done correlation analysis. So can we just we can throw some light on that also, that for nominal data only we do the chi-square test, and for the rest of it, the numeric data, we do correlation analysis and correlation coefficient, right?
Yes.
Okay, but we have not heard anything about the ordinal data. Can you throw some light on that? Like what we can use in the case of ordinal data?
See, ordinal data is something like you are going to rank, right? Suppose it is something like high, low, medium. So I don't think there will be any relation, right?
There will be no relation in this?
Yeah.
Okay, cool.
So I assume for ordinal, we are going to have this discussion, but there is some question which is different from our slides in the sample paper. They have asked, assume all attributes are ordinal. So Anu, as you go ahead, I think we will take this topic. This is something different.
Yes. See, we will go for, see, that I remember that is different topic. Okay, that's not related to this one. So we will take that in interest of time. Okay, I'm just going with the next topic now.
Yeah, please.
And I will unmute you all again. I mean, I'll mute you all again. Just a minute. Okay, next topic is binning. Okay, so now what is binning? Binning is nothing but you want to reduce some noise. Okay, you have set of values, and if you see that you want to smooth your data, you want to remove the noise, you want to remove the unwanted, or it's not unwanted, you want to smooth your data. Instead of having so many different values, you want to make the values something like less number of different values. Okay, let me say like that. Okay, next we will see what are the different ways how we can do binning. You can do equi-width binning. Okay, equi-width partitioning. You can do equi-depth. We will see all that. In equi-depth, you have again, you can smooth by bin means, by median, by boundaries. Okay, We will see each one. Okay, first equi-width. Equi-width means max minus min by k. Whatever your maximum value minus minimum value divided by k. K is nothing but the interval of same size. This k value will be given to you. Okay, with what is your size of interval that you have to take. Okay. Now equi-depth means number of values in each bin. If I say k is equal to 3, that means you can have only 3 values in your each bin. Smoothing by bin means is like after you partition your data into different bins, you have to replace each value in the bin with the mean of that bin. That means, suppose if you have 3 values in particular bin, you calculate the mean value and then substitute that mean value for replace all your values with that bin value, mean value. By median means you calculate the median and then replace all your value with that median. Equi-depth by boundaries means replace each value in the bin with the nearest boundary value. I will not explain here. Let's take a problem. So this one problem I have taken from previous mid-sem. So if you see here, this is a set of data that is given to us, and they have given us k value that you have to create sets of 3 bins. Okay, and you have to do equi-width, equi-depth. Both the binning methods they have asked us. Now coming to equi-width, we have seen above the formula is max minus min by k value. Okay, so what is the max value here? 30 and min value 1. So 30 minus 1 by 3. So you have got 9.66. So then what will be your range? So start from 1, add 9.66. Okay, so the first bin range will be 1 to 10.66. Now in 10.66 again you add 9.66. So the second bin range will be 10.66 to 20.33. Again to 20.33 you add 9.66. Your next range will be 20.33 to 30. Okay. So if you see how the marking is, so just to find out the range, 0.5 mark, okay, half mark. And then you partition your bins 1 mark. For equi-depth, so the marking is like this. So just to make you understand that you have to write each and every step. Okay. Next is after you found the range, you have to divide your data into different bins, equi-width bins. Okay. Now if you see, first range is 1 to 10.66. So what are the values that fall between 1 and 10.66? 1, 2, and 8. After 8 we have, so always better, first arrange this in ascending order. Okay, then it will be easy for you to find out if suppose we are given with a large number of values. Okay, 1, 2, and 8. And the second is 10.66 to 2.33. So what are all the values falls between 10.66 and 20.33? That is 11 and 20. Okay, there is no other value greater than 20 that falls here. Next is 20.33 to 30. So rest of the values, that is 23, 29, and 30 falls in the next range, and 21 also. So this is equi-width bins. Okay, you have found the range of your bin using this formula. Next is equi-depth. Here also what you have to do, k value is given as 3. Equi-depth means each bin will have how many elements. You have to divide your data into 3 bins only. Okay, that's why they have given 3 here. So how do you do? Count the number of elements that you have here. You have 9 divided by 3. So that means each bin will have 3 elements. So you just take, if you arrange in ascending order, first 3, then next 3, then next 3. Okay, this is how you have to divide your bins into equi-width and equi-depth. Now we saw that smoothing by bin means by bin median, by boundaries. If this part is also asked, then how do we do? So this is again one more problem. So I've taken some set of data, and then okay, you have to calculate the, so k value is given 3, minimum value is this, maximum value is this. Okay, so find out the width. Width will be max minus min by k. So now width you have got 70. So what will be your intervals? Intervals will be some 0 to 70, then 70 to 171 to 140, 140 to next, okay, something like this. So divide your data into 3 bins, bin 1, bin 2, bin 3. Bin 1 will be the values that falls between 0 and 70. So all the values you take between 0 and 70 and put it here in bin 1. Bin 2 will be 71 to 140. So just to check all the values that is between 71 and 140, that is 72 and 92. So similarly, you can check for bin 3. Okay. I will tell about this one. Yeah. Now partition into equal frequency bins. So if you take this data, first equal frequency means each bin will have 3, like 4, 8, 15, 21, 21, 24, 25, 28, 34. You are divided into 3. But now how do you smooth this by bin means? So you have to find the mean value of each bin. That means you have to find the bin value of 4, 8 and 15. That is 9. Then replace each value here with 9. Similarly, you have to smooth this particular bin by bin means. You find the mean value of 21, 21, 24, and that is 22. Replace each of this with 22. Similarly for bin 3. Now smoothing by bin, if by bin median, if it is given here, so then what you have to do, you have to find the median of 4, 8 and 15. Okay. And then you have to replace each of the value with that median value. Okay. Now smoothing by bin boundaries. Bin boundaries means, now here we have only 3, right? So it will not be very clear from here. Suppose if we have 5, 6 values, right, then it would be more clear. But let's see. So if you see, 4 will be your minimum, 15 is your maximum. In middle, what is left out? 8. Now 8 is near to 4 or near to 15? It is near to 4. So replace 8 by 4. Replace 8 by 4. Now if you see 21, 21, 24, it's already smoothened. If you see this is min value, this is max value, 21, the middle value is also 21 only. Now coming to this one, 25, 28, 34. This is your minimum, 25, maximum is 34. If you go to 28, 28 is closer to 25. So you replace 28 by 25. That means you are smoothing by bin boundaries. Let's suppose if there would be one more element here, 31, let's say. So that means 31 is near to 34, right? So then we would have replaced 31 here with 34. That is the maximum. So boundaries will remain intact. The lower boundary and the upper boundary. In between values, you have to smooth by using the closest bin boundary. Okay. So this was all about binning. Next is mean value. So I will not go deep into this. So just I will tell why do we use mean. Mean is to find the dispersion of the data. Like how dispersed your data is. I mean, what is the central tendency of the dispersion? Okay. This will measure your, this will be measured by your mean value. So, okay. So mean, I think everybody is very clear. You have to just do the summation of all your values given divided by number of tuples. Okay. Now coming to weighted arithmetic mean. Weighted arithmetic mean is nothing but for each value there will be some weight given. Weight means some frequency. Let's say for A, like now suppose let's say A is some gender, female, male. So how many males? 4 males, something like that. Okay. So that is the number of values for a particular attribute type. That frequency will be given. So you have to multiply that frequency with that value and then do the summation. And in the denominator, you will have the summation of all that frequency. That is called as weighted arithmetic mean. This is nothing but some weight of each value is given. So you have to consider that also. So that's how you can find the weighted arithmetic mean. So just I have taken one problem. So this is a set of values given to you in thousands of dollars. And then you just find out the mean. Just add up all these divided by total number. How many number of elements are there? Okay. Next is median. So median is nothing but middle value of odd number of values. Suppose if you have something like this set of elements is given, and if they are odd number, okay, here how many we have? 12. This is not odd, this is even, okay. But if suppose odd number of values is given, then you take the middlemost value as your median. But if suppose even number is given, number of values are even, then you have to take the average of middle two values. Okay, we will see the problem, then you will understand. This is for normal data. This particular first two lines is just for normal set of values that is given. But some grouped data is given, something like this, like age 1 to 5, how many people are there between age 1 to 5, 200, how many people are there between 6 to 15, 450. In this case, how do you find the median? So in this case, the median formula is this one. L1 plus n by 2 minus summation of frequency of L by frequency of median into width. Now let's understand how do we calculate this. What is L1? L1 is the lower boundary of median interval. So in this data, whichever is the median interval. Now which is the median interval here? First two you leave, and now these are even numbers, right? So sometimes I saw one problem, median interval was given. They have told that consider 1620 as median interval, okay? So here even number, I think we can consider 1620 as median interval. So if you take this as median interval, what is the lower boundary of this median interval? 16, okay? And n is what? N is nothing but number of values in the entire data set. That means you have to add up all this, okay? Sigma frequency of L is the sum of frequencies of all the intervals that are lower than the median interval. That means you have to take sum of all the frequencies below the median interval, which are less than the median interval. Which are all the less than the median interval? 6, 15, 1, 5. So you have to take all these above values, sorry, not the lower values. It is all the median intervals which are lower than this median interval. All the frequency of all those intervals. You have to summation and then put it here. And frequency of median is the frequency of the median interval, which is nothing but 300 here. 300s. And width is the width of the median interval. That means 16 minus 20. What is the width? 4. So that is the value here. So it is very clear from here. And then we can just substitute the values. Okay. So if you see the problem, here we have even number of observations, right? So what you do first, you have to arrange this in ascending order. And then how many observations are there? 12. Okay. So median will be middle two most values you take, can be 52 and 56. Okay. So you have to take the average of 52 and 56. That will be your median value. So this is a salary in $1,000. So median salary will be, so finally you don't write the answer median as 54. Okay. You have to convert it into that unit that they are that they have given the data for. Like they have given for $1,000, you have to convert your 54 into that $1,000. Okay, so that will be your median salary. Okay, next is range. Okay, now range is nothing but a difference between your max and min value of your observations. Okay. So this is also another one formula where you find out how your data is distributed. So this is just a simple range is max minus min only. This is important. Quartiles is important to understand. So quartiles are nothing but the points that are taken at regular intervals of data distribution. That means they are going to divide your data into equal size of consecutive sets. Okay. So in quartiles, we have 3, Q1, Q3 and Q2. Okay. Q1 is your 25th percentile. Q3 is your 75th percentile and Q2 is your 50th percentile. Okay. Q2 is nothing but your median. and Q3 is 75th and Q1. We will see how do we calculate. So this particular problem is an important one. And I see that 5 number summary has been already asked in previous exam. Just try to understand how do we calculate it. Interquartile range is IQR Q3 minus Q1. Just remember this. Interquartile range also has its importance. We will see why do we need interquartile range. Now for calculating 5 number summary, so when this problem comes, you have to write like this only. 5 number summary formula for this is a formula only for 5 number summary. First you have to write minimum, then Q1, then median, then Q3, and then max. Now minimum you will know, okay, maximum you will know. How do you calculate Q1? Q1 is 25th percentile. In my earlier document that I sent, this is wrong, okay. I had put minus, but it should be plus. So 25th percentile will be 25 by 100 into n plus 1th term. Okay. 75th percentile will be 75 by 100 into n plus 1th term. We will see this with formula, with problem. Okay, then you will understand clearly. So to all these values, there is one plot related called box plot. This is also one problem that has been asked earlier. So when you have to draw a box plot, you draw a number line. On that number line, you mark your values. And then you have to draw, then you point minimum, wherever your minimum value fall, put one this small line. Then for Q1, you put one small line. For Q2, you put a small line. For Q3, you put a small line. Join your Q1 and Q3 and form a box here. Okay. This is called box. And then you extend these lines to until Q3, until max and until min value. These are called as whiskers. These are called as whiskers. Mark everything in this box plot. Mark everything. Mark your Q1, Q2, Q3, max, min. Everything you mark just like this, how it is there. You mark this IQR also. IQR is nothing but your Q3 minus Q1. So all the values that are falling between Q1 and Q3 will be your IQR range. Okay. What is outliers? So all this has been asked in one problem. Okay. Outliers is data points that are below and above the lower and upper limit. So that's where we need IQR. Okay. If you want to find all the outliers, outliers are the values which we are not interested. We want to remove them. Outliers are the values which falls below this and above this. That means lower value is Q1 minus 1.5 IQR. Upper value is Q3 plus 1.5 IQR. All the values that fall below this lower and above this upper, you are going to consider them as outlier. Okay. So in one of the problem, they have asked to find out the outlier. So in order to find out the outlier, you can find this range, this lower and this upper. Okay. And then all the values below lower you can remove, all the values upper you can remove. Those are considered as outliers. Let's see the problem, then it will be more clear. So these are set of the values 19. So I've given some set of the values. Okay. Now first you have to arrange them in ascending order. Now your median is your Q2. That is your second quartile also you can call. Okay. How many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is an odd number. So 9 means your middle value. So if you remove 4 here, your Q2 will be your middle value. That is 5th term. Okay. So 5th term will be your median. That is Q2. Now what is your lower quartile? Lower quartile Q1. So how do you find lower quartile? What is the formula? 25 by 100, that is 25th percentile, right? 25 by 100 into n plus 1. So n plus 1 means how many values we have here? 9. 9 plus 1 is 10. So 25 into 10 by 100, that will be 2.5th term, right? 2.5th term means 1, 2, and what will be a 2.5th term? between 20 and 21, that will be 20.5. So that will be your Q1. Okay. And what is your upper quartile Q3? That is 7.5th term. How did we come this? How did we calculate this 7.5th term? 75 by 100 into n plus 1, which is nothing but 9 plus 1, that is 10. So 75 into 10 divided by 100, we will get 7.5th term. So what is your 7.5th term? 1, 2, 3, 4, 5, 6, 7. And what is your 7.5th term? That is 25, between whatever value that comes between 25 and 27, that is nothing but 26. Okay. So that is your Q3. So how do you write your 5-number summary? 5-number summary is 5 things that you have to write. 5 elements: minimum value, 25% value, median, 75% value, maximum value. So you can just write down all that. Okay. This is another problem I have taken, I think. Yeah, I will not explain this. Let's go to IQR. So IQR is nothing but your Q3 minus Q1. Okay. So what is the significance of IQR? As I told earlier, it is going to find out the outlier that is present in the data set. So this is the data set for which we have calculated this IQR. So now here this 27 is the outlier, but by seeing this data you will not know, okay, which is outlier here. I mean, here we can come to know because 27 is like very far value, but suppose lot of values are given, then how do you find the outlier? What you do? Find out the lower bracket and the higher bracket. Lower bracket is nothing but Q1 minus 1.5 IQR, higher bracket Q3 plus 1.5 IQR. So all the values that fall below minus 0.5 and all the values that fall above 18. So what is the value that is falling above 18 here? That is 27. Okay. So 27 is your outlier. That means you will take only the values between minus 1.5, it should be minus 1. Here also I've written wrong. It should be minus 1.5. So you have to take all the values only between minus 1.5 to 18 are only the elements between, I mean, for which you will take the values, and others you will remove as outliers. Okay. I'll correct it later. It's coming now. Okay. Yeah, this is the box plot. I have already explained, right? This is for this above data. Okay, here what was the Q1 value? Q1 was 3. Q3 was 9 and Q2 was 6. So if you see this box plot, Q1 we have Q1 is 3 here we have plotted, and this is 9, your median 6, and then your minimum value and max value. Just extend this whiskers. Okay, so this is clear. So outliers are, again, this is the same information. Yeah, this was all about your binning and box plot and min, median, outliers. Okay, so let's stop here and then take the questions from here, and then there's another document. Then what is the next topic? I think the next topic is this is over. This is over. Yeah, let's stop here and then continue from here. No, I'll just cover this also, variance and standard deviation. This is very straightforward. I'm not going to explain any problem. So this is the formula for variance and this is the formula for standard deviation. Already we have seen how to calculate. Variance is nothing but there is no square root here. That's it. That variance and standard deviation are like, variance is nothing but the square of standard deviation. Okay. Okay, let's take the questions if anybody has any. Yeah.
Hi, Anu. I had a couple of queries on IQR1. I just wanted to know, firstly, if suppose you have a data set with even numbers, then how do you calculate, like the median you can find out, but the Q1 and Q3, do you consider the two values, or you ignore the two values completely and then find out the Q1, Q3? Like for if you have an odd numbers,
Q1
you
and
can.
Q3. We have given this formula, right, for Q1 and Q3?
No,
20.
not that part. See, in Q1, Q3, like if you have an odd number of digits in the list, you can it is said that you ignore the median and then form Q1 and Q3 set and find the median out of Q1, Q3. But if it's an even number of set, there will be two values at the middle, from which you'll find you'll calculate Q2. But after finding Q2, do you use the two numbers to form Q1 and Q3 set, or you just ignore the two and then use the other?
We ignore Q2, and then whatever is to the left of Q2, you take a median, that's your Q1, and whatever is to the right of Q2, you take that median, that is Q3.
Because the value changes. If you are considering the two numbers and forming Q1, Q3 set, the median value will be different than if you ignore and calculate. That's why I asked that. That's the first point. And
yeah, I like to add here. It's basically you have to create two equal size sets. So if it is even, then it is very easy to form two boxes with equal number of data in it. And if it is odd, then you ignore the middle part and you form two equal sets with the data.
Why I'm asking is because I found some videos in YouTube where they are saying that once you have taken the median, you split the median, the two values, into one Q1 range and one Q3 range, and then find the median for Q1 and Q3. While in our lectures on nothing has been told about this, so I was like confused whether we have to do this, whether we don't have to do it. So
once you find Q2, the Q2 you will not count. Okay,
but that's for odd number of variables.
That is for odd number,
yeah. But for even numbers, there is no example in our lecture.
Again, you take a mean for Q1 also. If you have even, again you take a mean.
See, I'll explain. See, say suppose you have 10 data sets, right? 10 data points. Right? So in the left data set you have 5, and in the right one you again have 5.
Yep. So if you are taking 5 and 5, that means you are considering the the median values that you used for calculating Q2.
See, the median here will be the mean of those two middle points.
Yeah, 4 and 5.
So it will be anyhow. It will be in between those two values, which will come, which will fall.
That part I'm clear of. That how you calculate the Q2, I'm clear of that part.
Will it be good to take one example and discuss?
Yeah, like in that set where we have 9 numbers, just ignore the last one, and then maybe we can try and see how do you calculate, because that's the confusing part which I'm having.
In the class for even number, we will take for the median, it will be the 5th and 6th number, right? For the Q1, we will take from 1 to 5, and for Q3, we will take from 5 to 10.
So 6 to 10, yeah. So that means they are using the median, the numbers.
Median
yeah.
number.
So okay, yeah. So that's now, if somebody has cleared in the lecture, that means it is correct one, because in our lectures it was not covered. That's why I was just clarifying it. And second, the doubt I had in min and max, do you use the minimum and maximum value of the list, or do you use the value calculated by minus Q1 minus 1.5 IQR or Q3 equals to? See, when you are calculating in box plot, so there is a min max. So in 5-point summary which you write,
this IQR is nothing but max of this. Like suppose this is a data set given. So what is the maximum here minus minimum?
Yeah. So when you're writing the output, saying the 5-point summary.
No, not maximum minus, sorry. Q3 minus Q1, sorry.
No,
But
I
5-point
understand
summary is
It will be
different.
taken from
I
the
think that
data
is
set.
different.
It will
It
be
is only
taken from the
minimum and
data set.
maximum for 5-point summary. So this is different.
No,
So,
that might be wrong. That might be wrong if you'll directly take the minimum and maximum. Why? Because if
Min
you
and max is nothing but you avoid all the outliers. Okay, you remove the outliers, and then see what are the data you have. The minimum data is your min, and the maximum data is your max. You remove the outliers.
correct.
I mean, as per book, we find out the min and max of the given list. If they are the outliers, then we plot 1.5 IQR for min and max. But if they are not outliers, then we plot the min and max of the list itself.
Yeah.
first you'll have to find out if the
that min max do not change, and it will
Min
be
max
the
will not be
do
a
not
part of
change.
outlier.
But when you are drawing the
Yeah.
box plot, then you would actually either place the outliers outside the line. But the min can be also in outliers, max can be also outliers, but min max value would not change.
Yes.
That is
Yeah.
only min or max.
Yes, it
So-
will be from the data.
So basically, we will be taking the min max of the list, not the values we calculate.
Yes.
Yeah, that's what the ma'am in the class also mentioned.
Yes.
Okay.
Yeah, I'll have a different opinion here, right?
No, actually,
if you consider min and max, consider it as the lower boundary and the upper boundary, because if you consider it as the minimum value of the data set and the maximum value of the data set, then the outliers will be within the box plot.
That's what was my confusion was.
So here there is a problem in notation. I also faced this problem, and when I went through the literature, then it was clear that the min and max what is written on the screen right now, it should be the lower boundary and the upper boundary, which is calculated with the formula which is written here as lower and upper.
Different. My understanding as per the book, drawing is different, and min max when we are giving this 5-point summary, that would be actually min
Okay,
and max.
so basically the issue is the notation that they have used, min and max in box plot, is wrong. It should be lower and upper, but min and max is the min and max of the list, not the one which we calculate over here with the use of IQR.
Always everywhere it has been mentioned that the outliers are beyond this min value and the max value which is written here, and if it is not within the set, then there will be no outlier altogether.
Okay.
Okay, we will park this as a question. I think there is a lot of the confusion around this. So we will park this as a question, and we will discuss it by finding out about it. Okay.
People can mention it in their answer sheet also separately if they want.
Yes. So let's find it out. So this is one open question.
You can
okay?
write 2 min and maxes in the answer sheet.
No, instead of min and max, you can use this different term like the lower boundary of the
Okay.
I think we can keep it very simple. The minimum is minimum for any data set, maximum is maximum for any data set. We are only writing Q1 and Q3. Q3 doesn't cover the maximum value, or Q1 doesn't cover the minimum. So there is maximum value is beyond Q3, minimum value is less than Q3. So that's fine, I think.
The question here is whether
Minimum
the
is
outliers are part of the min.
Q1 minus.
We should move on.
Outliers can be part of minimum value also and can be part of maximum value also.
Yes, that's what I am saying. It can be part of minimum and maximum.
So this is very simple.
Yes.
We are only talking about Q1 and Q3. Q3 is your 75th percentile, where 25% values are above that. That is 75th percentile. Q1 is 25th percentile, which means 25% values are below that. So min and max are absolutely fine here.
No, but that will change the definition of outliers.
I think Anu, we should move on.
Outliers are something which are beyond. So you take the lower range where you see that 25th, there are values which are in the range of 25th percentile, but some values are going too far below. That is the outlier.
How far below?
Yeah, that question, that is 1.5. 1.5 of Q1.
So what I'm saying, Q1 minus 1.5
Yes.
IQR, Okay,
Yes.
whichever falls in that is only your min. Outlier is not your min. That's a mistake you guys are making.
Outlier is Q1 minus 1.5 IQR.
Yes,
So
that's
that
what
is,
I'm saying.
so that is given.
Anything goes beyond that, that's an outlier, and that outlier is not your.
Sorry guys, I had to mute, okay, because see, we cannot discuss continuously. I know there is some confusion around this one, but as per my understanding, I just want to make it clear that it is min and max, normal min and max of the range of the data, and your outliers can fall here, okay, in the box plot bit above Q3 and below Q1. So that's where we are finding this lower and upper value, okay. Lower and upper value is nothing but your values that you have to consider, outside this lower value and above this upper value, you have to consider all the data points as outliers. But as per my understanding, min and max is nothing but the min and max of the given data. But still, if we are not convinced with this, we can discuss it separately, okay. Let's keep this as open question and come with more data points, okay. Let's go to the next topic. Next is dissimilarity matrix, okay. So we have left with less time, so I will just go little fast from here. So dissimilarity matrix is nothing but we are going to find out. So now what we are going to do in this kind of numericals, we are going to find the similarity between two tuples, okay. How similar they are, how dissimilar they are. So this is your dissimilarity matrix. In this matrix, see, all the diagonal elements will be 0. Why? Because here, what will be the diagonal element? What are the two different tuples you will be considering here? D of 1, 1. 1, 1 means you are just comparing that element with itself only. So there will be no difference, right? Then that's why we write it as 0. The upper boundary elements, upper diagonal elements are all same as this will be the reflection of the lower boundary elements only. Because if you take D21, so here it will be D12. So D12, the difference between second and first will be same as first and second only, right? So in dissimilarity matrix, you have to just fill only these values, okay, below the diagonal element, and all your diagonal elements will be 0 because they will be similar to each other, because it is something like you are comparing it to itself only. Now, what is your similarity? So you denote dissimilarity with D of ij. I is your first row 1 and j is your tuple 2. You are comparing tuple 1 and tuple 2, or you can say attribute 1 and attribute 2, okay. So D of ij will be equal to D of ji, I already explained, and this is called dissimilarity. D is dissimilarity, how dissimilar they are, and similarity is nothing but how similar they are. So what will be your similarity? It will be 1 minus your dissimilarity value. So this will be useful when we go further. So this is just notations, okay. Okay, let's see how do you measure the proximity? How do you measure the similarity, dissimilarity of a nominal attributes? Now, for nominal attributes, what is nominal attribute? We know, right? Nominal is something like 10. Here, you cannot call it as numerical also, like type of something, A, B, C, like doctor, scientist, whether the person is what is its profession. So those kind of attributes are called nominal attributes, okay. Now, if you see here, we have given with some 4 tuples. We have 2 attributes, type 1 and type 2. Okay, type 1 has these values, type 2 has these values. You have to find out the similarity, which 2 tuples are more similar, So the formula is, so dissimilarity between any 2 tuples is given by P minus M by P, where P is the total number of attributes and M is the number of matches, okay. Let's see how do we calculate. So if you want to find the similarity between 2 and 1, or let's say dissimilarity between 2 and 1. So you write D of 2, 1. P is total number of attributes. What are the total number of attributes we are having here? 1, 2, 3. No, sorry, not tuples. Total number of attributes, how many we are having? Type 1 and type 2. So we have 2, right? And if you see, between 2 and 1, between second tuple and first tuple, how many values are matching? How many attributes are matching? So 10 and 30 not matching. A and B not matching. That means both the attributes are not matching. That's why 0. By total number of attributes is 2. 2 minus 0 by 2. So dissimilarity value have received 1. Similarly, you find between 3 and 1. Between 3 and 1, how many attributes are matching? 10 and 10 matching, number 1. A and A matching, number 2. So 2 attributes are matching. So what is the value of your M? How many matches you have got? 2. So that means dissimilarity between 3 and 1 will be 2 minus 2 by, again I have written wrong here. It's not wrong, maybe I think my pen did not work here. Here it has to be 2, okay? 2 minus 2 by 2. So it should be 0. Okay. So D of 4, 1. Similarly, you find a dissimilarity between 4, 1, 3, 2, 4, 2, 4, 3. Okay. All the tuples, we have found the dissimilarity value. Now plot your dissimilarity matrix. You just put all the values in matrix. Now if you see, now which is more similar? Which tuples are more similar? Now for whichever dissimilarity value will be 0, they are more similar. They are similar basically. So dissimilarity, if it is high, that means they are not similar. If it is 0, that means they are similar. And you calculate similarity 1 minus D of ij. So if you do 1 minus 0, that means for D of 3, 1 is dissimilarity value is 0. If you take 1 minus 0, similarity will be 1. That means if similarity is 1, that means they are more similar. But if dissimilarity is 0, then you say that they are similar. Okay. So this is for nominal attributes. Next, coming for binary attributes. Now, you know, in binary attributes, we have all ones and zeros only. Okay. Binary means two values, 1 and 0. Now, for binary attributes, we have two types of binary attributes: asymmetric binary data, symmetric binary. I think you know what is the difference between asymmetric and symmetric. So if you take gender, we have two, male and female, and both are given equal weightage, right? You cannot say that you can mark 1 for male and you can mark 0 for female, right? Both are equally important. But if I take some data, something like high, low, not high, low. Symmetric data is something like medical test. Let's say we take HIV. Okay, for HIV positive, we mark 1. For negative, we mark 0, because negative is something taken in negative way. So those are called symmetric binary data. Okay. So now for both of the data, we have two different formulas: R plus R by, I will tell what is this R, what is SQ, T, I will tell. So this is the formula for calculating the dissimilarity between any two tuples of a binary data. Okay. And this is your Jacquard coefficient. This is one problem asked on this particular Jacquard coefficient formula. Jacquard coefficient is nothing but similarity for two tuples for asymmetric data. This coefficient is for only asymmetric data, and formula is Q by Q plus R plus S. Okay, now if this formula is clear, let's see this and understand how do you calculate your Q, R and ST values. So this is your table. Now you have to find the dissimilarity between, let's say, X and Y. Your I is nothing but X, J is nothing but Y. So you draw this contingency table. In this table, you write object I here and object J at the top. Okay. Now your object I is nothing but X, object J is nothing but Y. Okay. Just write 1 0 1 0 here, Q R S T. Just first you draw this table. Now find out Q value. What is Q value? Q value is nothing but number of attributes for which I is 1 and J is 1. That means number of attributes for which X is 1, Y is 1. Now how many attributes X is 1 and Y is 1? 1, 2. That means your Q value will be 2. Q is 2. If you see, I have marked here Q is 2. Okay. I'll take this. I don't know if you are able to see what I'm saying. Yeah. So here Q is 2. Okay. Now for R you have to see how many tuples, how many attributes for the two tuples? Object I is 1, object j is 0. Okay. So this object I is 1, j is 0. Now let's see. I1, j0. There is no tuple. That means value for R will be 0. Okay. So R is 0. Now coming to S. S is nothing but your object J is 1, object I is 0. So X is 0 and Y is 1. X is 0, Y is 1. Just check where. Only one tuple. Only one attribute. Sorry, not tuple. One attribute. That is T5. So that means your S value is 1. So now you received all your values. So you have to find. So this is the formula. This is your formula. Substitute here. R plus S by Q plus R plus S. Substitute. So you will get the dissimilarity between D of XY. That means between these two tuples. Okay. Similarly, you can find between X and Z this and this. So now your object I will become, this will be your object I, and your object J will be this. So now you have to consider this and this, this and this. And then you have to find out your Q, R and S value and substitute and then find this. So I'm not going to do, I've done for 1. So similarly, you can find for XZ, XY, XZ and YZ. Okay, these three combinations only we will have. Now, which two tuples are more similar? If you see, this value we got 0.33. So, which is the least value? Which is the least value here? 0.33. We know that dissimilarity, whichever is having the least value, those two tuples are more similar. Okay. So, this is how we find for binary attributes. Okay, but be aware that if it is symmetric binary data given, then you have to use T also. And T is nothing but where object J is 0, object I is 0. Both are zeros. Okay. Yeah. Next is Minkowski distance. Okay. So I am really not very clear what is the significance of this Minkowski distance. But this is one more method of finding out the similarity and dissimilarity. And I see that for this Minkowski distance, there are this is something like in maths also we have, right? We find the norms, L1 norm, L2 norm, L infinity norm. Here they're calling it as supremum. Okay. So actually the Minkowski distance formula is this. Dissimilarity between I and J is given by this formula. Here your H, based on your H, you have three different formulas: Manhattan, Euclidean and supremum. For H is equal to 1, if you write here, that means this root will go off. So your formula will become absolute value of xi minus xj, xi2 minus x2j. So we will see the problem. I don't want to explain the formula. For L2 norm, it will be H is equal to 2. So when H is equal to 2, if you substitute here, then your formula will be deduced just like this. And if you put H is equal to infinity, then you will be having this. This is your supremum, formula for supremum distance. So we will see an example. So this is a table given. So these are all the variables, tuple names, and then these are the attributes. So if you have to find the dissimilarity between x1 and x2, first we will take Manhattan. Manhattan formula is this one. Okay, absolute of summation of differences. So how do you find x1 and x2? Now 3 minus 1, 2. Or you can say 1 minus 2 also. Anyways, it is absolute. I mean, you are doing that absolute value only you are taking. Okay. 3 minus 1, 2 plus 5 minus 2, 3. So 2 plus 3, 5. This will be 0 because difference between x1 and x1, nothing. It's comparing to itself only. difference between x1 and x2, dissimilarity between x1 and x2, x1 and x2, this. So 3 minus 1, 2 plus 5 minus 2, 3. 2 plus 3, 5. Again, between x2 and x2, it is 0. Again, x3 and x1. So if you take x3 and x1, 2 minus 1, 1 plus 2 minus 0, 2. 2 here, 1 plus 2. How much we got? 3. Similarly, you can find for x3 and x2, this and this. So 3 minus 2, 1 plus 5 minus 0. How much? 1 plus 5, 6. So you can plot all your values like this. Okay. Next is Euclidean. For Euclidean, what we have? This is square and then root. That means if you have to find the difference between, dissimilarity between x2 and x1, 3 minus 1, 2 square, it will become 4. 5 minus 2 square, it will become 3 square, 9. So 4 plus 9, 13. You have to take square root of 13, which will be 3.61. So for x3 and, let's take one more. x3 and, next is x3 and x1. So this and this. So 2 minus 1, 1 square plus x3 and x1, right? There is another attribute, 0. 2 minus 0, 2, 2 square. And then you have to take the square root of this whole. So that will be your, this x3 and x1 value. This is how you calculate your L2 norm. Next is supremum. Supremum is nothing but max. So now for this attribute, if you say x1, between x1 and x2, if you find the dissimilarity, for this attribute, what is the value? 3 minus 1, 2. For this attribute, what is the value? 5 minus 2, 3. Now, which is the maximum here? 3. So we write 3. Similarly, for x3 and x1, if you take this 2 minus 1, 1. 2 minus 0, 2. Which is the maximum? 2. So we write here 2. So you have to take the maximum. Suppose there is one more attribute here. Okay. You have one more attribute. Then you calculate for that attribute also, and out of 3, whichever is max, you have to take here. Okay. I think this is clear. This is Minkowski distance. Next is proximity measure of ordinal attributes. Ordinal is something like high, low, medium, where you can assign some rank. Okay. So now if you see, I have this object, I have this set of data. Here I have assigned high as 1, medium as 2, low as 3. Okay. First, we can normalize this between this 1, 2, and 3. We can normalize between 0 and 1. So that, because if you suppose if you have more classes, if you have more high, medium, low, here we have 3 only. Like this, for some kind of data, we may have 10, 15 also. Then you assign the rank 1, 2, 3, 4, 5, 6, 7 till 15, right? But then you cannot keep on taking that values till endless, right? So you have to normalize that rank between 0 and 1. So you know how to normalize, right? So I'm not going to tell about normalization here. So after normalizing, we received this value. So for 1, we got 0, 0, for 2, 0.5, for 3, 1.0. Okay. Now, how do you find the dissimilarity between 2 and 1? Between 2 and 1. That means between low and high. Low, for low, what is the value? For low, we have received 1 normalized value. For high, 0. So 1 minus 0, 1. Okay. Now between 3 and 1, 3 means medium and high. What is the value for medium? Medium is 2, right? 0.5 and high 1. So 0.5 minus 0, 0.5. So you can calculate for all, okay, for 4, 1. So you should calculate between 1, 2, 2, 3, 3, 4, then 1, 3, 1, 4, 2, 3, 3, 4. So all when you calculate, you can write in your matrix form, and then you can find out your dissimilarity. This is very straightforward. This is for ordinal attributes. Okay. Next is for mixed attributes. So this is the problem where so many people have many doubts. So I will not explain any formula here. we will directly take this mixed attribute problem. So if you see here, we have income, which is a numerical, we have nominal, profession, mother tongue, we have a ordinal, native village. Okay. Now, if you see in the problem, they're saying that based on the information given, find the most similar and most dissimilar person, apply min-max normalization on income to obtain between 0 and 1 range, consider profession and mother tongue as nominal, and consider native place as ordinal. Okay. And ranking, we have to rank in this order: village, small towns, suburban, metropolitan. Okay. And we have to give equal weight to each attribute. So this is the problem. This is your table. Now, once you normalize, so I know, I think you all know how do we normalize your income. Okay, between the range 0 and 1 using min-max normalization, you will find this. So just you write profession and mother tongue are nominal, you write as it is. Assign the ranks for village. So in this order only, 1, 2, 3, and 4. Okay, we assigned the range. Now, you have to find the dissimilarity between Ram and Balram. So how do? You have to add the dissimilarity of this. Okay. Now, for numerical, how do you calculate? This minus this. You will get 0.67. Now, if you see here, profession. Here it is doctor, here it is data science. Whether they are similar or dissimilar, they are dissimilar. So, whenever they are dissimilar, dissimilarity value will be 1. So you write 1 here. Bengali and Hindi, it is different. So 1. Now coming to ordinal attribute, how do you calculate for ordinal attribute? You take this formula. Okay, this formula you should take for ordinal. This is nothing but your rank minus 1 by maximum minus minimum. So I'll just tell you. See if you see here. What is the value here? 2 minus, what is the upper value here? 2 minus 1 divided by, what is the max value here? 4 minus 1. So this formula we have taken, and then we got 3. Similarly, if you take Ram and Bharat, okay. So what is the, so now here this is clear, okay. How do you calculate between Ram and Bharat? This minus this, 0.6 minus 0.33. Plus how they are, doctor and carpenter are different, 1. Bengali and Hindi is different, 1. And then how do you calculate as per that formula? What is the upper limit? 3 minus 1 by 4 minus 1. So this is how this 3 has come. And you find between Ram and Kishan. Okay. So 1 minus 0.67 plus, now doctor are same. Okay. That's why 0. Bengali, Bhojpuri different, 1. And then you have to calculate for ordinal for this. So here upper value is 4. 4 minus 1 by max value is also 4. So 4 minus 1, that is 2.33. I think this formula we are using, okay. We have to use this formula here for ordinal attributes. This is for ordinal, okay, when you are calculating for mixed attributes. And similarly for Bharat and Kishan, 1 minus 0.33. Carpenter and doctor are different to 1. Hindi and Bhojpuri are different to 1. And then you calculate. Here it has to be, I think, 4 minus 1. Oh, sorry guys, I confused here. Okay, sorry. This is this between 2 different values, not okay. This is something like 2 minus 1. So when we are calculating for Ram Balram, 2 minus 1 by upper maximum minus 1. Okay, sorry. And here it is 3 minus 1 by maximum minus 1. Yeah. And similarly for here Bharat and Kishan, 4 minus 3 by max minus 1. Okay. So here also Balram and Bharat, it is 3 minus 2 by max minus 1. Yeah. So now if you see what is the values we have got, which are more similar, which are most similar here, for which our dissimilarity value is less, that is most similar. So for which the dissimilarity value is less? So for Balaram and Bharat, if you see, it is 0.67. It is 0.67 or 1.67. I think it is 0.67 or 1.67. It's 1.67 only. Okay. 1.67 is the least value here. So that means they both are more similar. And which is the highest value here? 3.67. So that means Balram and Kishan are most dissimilar. Okay. So this is how we calculate for mixed attribute. Next is cosine similarity. This is another formula to find the dissimilarity between two different tuples, D1 and D2. This is the data given. Just it's very straightforward. You take the dot product and then you take the mod value of D1 and D2. Okay. Dot product, you know, how do we do? Just 5 into 3 plus 0 into 0 plus 3 into 2, 0. So this is nothing but, I think you know the dot product. Okay. Take the transpose of this and multiply with this. And then mod of D1 and mod of D2. Okay. Next is Gini index. Okay. This is another important topic and a little complicated to understand. So I'll try to explain. So now, first of all, why do we go for all this Gini index? So now when you're doing classification, we use decision trees. Okay. If we are using decision tree, now which node you have to use to split your data? So in order to decide that, what is that, which attribute you need to use at your node, I mean at parent node to split your data, you should use Gini index. I mean, you should use some measure to find out which attribute will give you the best split. Which attribute will give you the best split if you want to find. Then there are many different ways, like you can use Gini index, you have information gain, you have entropy, you have gain ratio. Okay, all that we can use. So let's first say Gini index. So Gini index is nothing but at any node T, if you want to find the Gini value at that particular node, the formula is 1 minus summation of P of J by T. What is P of J by T? It is relative frequency of class J at node T. What is class? Class is nothing but your target attribute. Okay. I think, see, I cannot go deep inside that, but I assume that you all know what is a class here. Class is nothing but target. Like in set of data, number of positives and number of negatives. Okay. That is your target class. So what is the probability of that any particular class at node T? Okay, that's what is your Pj of Pj by T. I mean, instead of understanding the formulas, let's see the problem. Then it will be more clear. Now, if you take any data, class C1 and class C2. So for class C1, how many? What is the value? 0. And class 2, 6 means what? Class 1 and class 2 means what here? Let's say class 1 means a number of positives. Class 2 is nothing but number of negatives. Or it can be something like class 1, how many male? Class 2, how many females? Okay, something like this, some classification. Okay, so if I take at any particular node, if I have number of class 1s are 0, number of class 2 is 6, then how do you calculate your probability? For class 1, probability will be 0 by total 6. And for class 2, 6 by 6. So your class 1 and class 2 values you have received. So how do you find the Gini? Substitute in this formula. 1 minus class 1 value, probability of class 1 value, probability of class 2, this will be your Gini value. Okay. Similarly, if class 1 has 1, class 2 has 5. So P of 1 is 1 by 6, P of 2 is 5 by 6, and substitute in the formula. Now what do you infer from here? If you see here, you have pure split. All the values belong to class 2. For class 1, there is nothing. You have 0. This is a pure split. And this is not very pure split, but this is not very impure also. The value is close to 0 only, like 0.278. Suppose if we have 5 here and 5 here, then this is totally impure. You will get value as 1. For 5, 5, you will get Gini value as 1. Okay. So that means if Gini value is less than 1, that means less impurity. But if it is more, if it is 1, then it is totally impure. And if it is 0, it is totally pure split. Okay. Now, how do you do splitting based on Gini index? Now, this is your parent node. Okay. This is your parent node. At your parent node, you have total number of classes, total number of values for class 1 is 6. Total number of values for class 2 is 6. Now you have two attributes n1 and n2. Okay. Based on this n1 and n, I mean, you are going to split this. Some values to node 1, some values to node 2 based on some attributes. So how do you calculate the Gini index for children? Okay, after you have split it, what is the value formula? After you have split, this is the formula. We will just see how to calculate. Now, if you want to calculate for parent, how will you calculate this formula? Okay, 1 minus. So what will be the value? 1 minus probability of class 1 by square minus probability of class 2 square. Okay. Now for Gini of node 1, now you have split. We have splitted this like this. So at node 1, you have how many values of class 1? 5. How many values of class 2? 2. At node 2, how many values of class 1? 1. How many values of class 2? 4. So now how do you calculate Gini of n1? 1 minus probability of class 1 at node 1. So at node 1, what is the total number of values? 7. So 5 by 7 square minus probability of class 2, 2 by 7. So that is Gini of your node n1. Now Gini of node n2 will be what? 1 minus values of class 1, probability of class 1. What is the probability? 1 by, how many values are there here? 5. 1 by 5 square. For class 2, how many values are? 4. So 4 by 5 whole square. So you find the Gini of n2. Now, total Gini of these children. I mean, total Gini index of these children. What is that? How many values for n1 we have? 7. 7 by total number of values. How many? 12. 7 by 12 into what was the Gini of n1? This. Plus for n2, how many values total? 5. So 5 by 12 into Gini of n2. This is nothing but this formula only. Summation of, if you want to find the Gini index of your split. That means after you split this node B into node 1 and node 2, what is the total Gini value of this one? This is the formula. Okay. So Ni by N. Ni means total number of values at node 1. By N is nothing but total number of classes that we have. Okay. Into Gini of I. Gini of I means Gini of node 1. Gini of node 1, how much? 0.408. So this is how we find the Gini of this level of this node after splitting. I think Gini index is clear. One more problem I'll quickly tell. So this is the tabular data given. How do you find the Gini index? You have to find out which attribute should be chosen between Q1 and Q2 as a first splitting attribute. So why we are finding this Gini index? We need to understand which attribute will give us good split, best split. Okay. So how do you decide if Gini index is lesser? Whenever Gini index is for whichever attribute it is lesser, that will be your best split. Okay. Now if you see, how do you calculate for this one? This table is given. Draw a contingency table. In contingency table for Q1 and Q2, how do you write? For Q1, you write here class. So this is your target class. Okay. Plus and minus. How many values we have for target class? 2. Plus and minus. Now for Q1, what are the two different values? T and F. Right here. Q1 equal to 2, Q1 equal to F. Now you have to see how many T's are plus for Q1. 1, 2, and 3. So 3. How many F's are plus for Q1? 1, only 1. So 1. How many T's are minus for Q1? So how many T's are minus? Yes, there is 1. Okay, so 1. How many F's are minus for Q1? How many F's are minus? 1, 2, 3, and 4. So we wrote. Similarly, you write for Q2, the table. Now we will find the Gini index for Q1 and Q2. Now first you find without splitting. Before splitting, how will you find? How many plus are there? 1, 2, 3, 4. That means your first class 1 has how many values? 4. Class 2, 1, 2, 3, 4, 5. Total 9. So what will be your Gini of overall table before splitting? 1 minus 4 by 9 square minus 5 by 9 square. So this is the value. Now after splitting, we know this is the formula. Now first we have to find Gini of Q1. Okay. After you have split your data based on Q1, let's say. Now you have to find Gini of Q1. So Gini of Q1 formula is summation of Ni by N into Gini of I. So Ni by N means how many values are there which are true? I mean for T, 4. That means 4 by total how many? Number of total is 9 into Gini of I. Gini of I means Gini of this particular split where Q1 is T. That means 1 minus this formula. 1 minus, what is the number of positive here? 3. 1 minus 3 by total number of classes at this particular split is 4. 1 minus 3 by 4 whole square minus probability of class probability of class negative. What is the negative? 1. 1 by 4 whole square plus I think it is clear, right? I am calculating here Gini of Q1. Gini of Q1, this formula. Ni by N into Gini of I. Summation. Ni means, now we have for Q1 two different types. Type T and type F. So for first we take for type T. Next this is for type F. For type F, how many total classes we have? Total tuples we have 5. So 5 by N is total number of tuples into Gini of I. Gini of I means Gini of this Q1. Gini of Q1 means how will you calculate? 1 minus probability of class plus minus probability of class minus. Okay, 1 minus probability of positive class square, probability of negative class square. So then this is how you calculate the Gini of Q1. Okay. Now delta Gini you should find. Delta Gini means overall Gini minus Gini of your Q1 value. Okay. So similarly you can do same steps for Q2. This Q2 split also. And then you find for delta of Gini Q2 also. Okay. So whichever attribute maximize the reduction in impurity or whichever has minimum Gini index is selected as splitting attribute. Now here for Gini of Q1, this is 0.151 and Gini of Q2 Gini of Q1 is 0.3441. This is delta, sorry. Delta is nothing but which has the minimum, which maximizes the reduction, okay? So Gini of Q1 is 0.3441 and Gini of Q2 is 0.4884. Now which one has a minimum Gini value? This one. That means it is Q1 will be selected as splitting attribute, okay? If you see that delta is more for this one and delta is lesser for this one. That means this is removing more impurity. Q1 is removing more impurity. Okay. So that's why it is selected as a splitting attribute. So this was about Gini. Okay, guys, I will again unmute here. I just want to know till here any doubt because this people may have doubt here. I will unmute and also we are left with 5 minutes only. So I mean, if people are interested, I will extend for 15 minutes more, whatever I can cover, 15 to 20 minutes. Just let me know, okay? I will just unmute you all. Yeah.
Anu, this is Kareem here. I think I asked you the same question. The one that you know, calculating the dissimilarity for the mixed attributes.
Yeah.
Why we didn't do like created 3 dissimilarity matrices for ordinal, numeric, and nominal, and then why we are doing here in a different way? I mean, that's what my question actually. I got confused, like in the PowerPoint, in the class, ma'am has explained in that way.
This is how our sir has explained.
Okay.
Actually, we can create the 3 matrices and also write. Actually, I checked the YouTube video. There he have created for each and every attribute, nominal, ordinal, whatever it is. He had created each matrix. From that, he was deriving the mixed attribute and then writing which is similar or dissimilar. It's like comfort. Everyone's comfort we can do. It's not a problem. Actually, our sir have directly explained these values, but we can get these values to matrix also. Both will be same.
Okay, got it. So here, whenever it is not similar, then we are putting 1 here, correct?
Yes.
Yes.
Okay.
That's it.
So this is dissimilarity, right? So when both are dissimilar, you take it as 1. Okay, that means they are dissimilar means high value means they are dissimilar. Okay.
No, that's the formula 1 minus m by p, where m is number of matching cases. If matching cases is 0, your overall output is 1.
Yeah, correct. But we can interpret it this way also, because here we are checking for each attribute, right?
Yep.
Hey, Anu, in this case, we have given native as ordinal, but I just shared one sample paper. The sample paper says assume all attributes are ordinal.
Here they mentioned in the problem actually.
Yeah. So all odd attributes they are asking to make as ordinal. Means how we will make all ordinal? Like for native we did 1, 2, 3, 4. So there is given height, income, weight. Should we make all as 1, 2, 3, 4? How?
It doesn't make any sense.
Yeah.
It doesn't make
If
any sense. So
I read the problem. Compare the proximity between the following pairs with
in fact,
supporting
even native doesn't make any sense to be ordinal. Yeah, it should be a nominal, in fact.
Yeah, maybe you can refer this mid-semester exam shared with all.
I've seen it. I think just for creating the problem, they have just given this, but it doesn't make real sense.
Yeah, really. I'm unable to understand.
Anu, can you explain once again, like 4 by 9, 5 by 9? How did it come?
Yeah, sure. I will explain. I know this will be more confusing. I will explain. Here you are saying. Oh,
yes.
See, here it is like overall Gini we are calculating before splitting. Okay, so before, just you forget everything. Just you focus on the target class. So in target class, how many positives we have? 1, 2, 3, 4. How many negatives we have? 1, 2, 3, 4, 5. And total number of attributes, tuples 9. So it is nothing but how do you read this one is probability of positive, okay, at any particular in a table, probability of negative. So that means how many positive we have? 4. So probability will be 4 by 9 and negative 5 by 9.
Okay, got it. Thank you. Yeah.
Okay, guys, do you want me to continue or
yes.
Yeah, maybe we can complete this entire thing and then.
If it is 1 hour more, then also it is okay. Anu. You're explaining too well.
Can you please take this example of how we are normalizing this 0.67?
Sorry, which one?
The normalization value that we got, 0.67.
Okay, this one is min-max normalization. See, we did first in the previous slides we did, right? How do you do is you have to normalize between 0 and 1. So you want to normalize this value, let's say. So what is your minimum here? This one. Max in this range is this. So formula will be B minus min by max max minus min into new max minus new min plus new
Got it,
min.
Anu. Thank you. Thank you very much. Thank you. Got it. Yeah. Thank you.
If you refer, you will understand the formula.
Yeah.
Okay.
Thank you.
Okay. Let's. I'm continuing. I'm just again muting everyone. Yeah. Okay. Next we go for what was that? Classification error. Yeah. So again, see, all this will look very similar. Okay. Gini, classification, entropy, gain ratio. Don't get confused. Don't try to understand. Okay. I mean, if you understand how each one is calculated, that's fine. Anyways, it's an open book exam, so you can go and refer. Just, I mean, when I explain classification error and then when I explain entropy, when I explain information gain, I am pretty sure everything will be a khichdi. Okay, you will think that all are same. Okay, but it's not like that. When you are solving, just refer to that formula. Okay. So now coming to classification error. So here also, this is also one of the measure to find the splitting criteria, which is good and which is bad. Now, if you want to find the classification error at any particular node T, okay. Now let's say you have class I. So for any class I, target class, this is your target class. How do you find 1 minus max of probability of I at node T? Whichever is maximum, that probability you have to take. So error before splitting, like how did we do for Gini before splitting? We can calculate first error before splitting. For Gini, there was some formula. For error, this is a formula. So what is the formula says? 1 minus max of probability of class at node T. So probability of positive, probability of negative. Which is maximum here? Maximum is this. So you have to consider that value and find the error original before splitting. Now error after splitting on node Q1. Okay. On node Q1, error after splitting. Actually, I did not write the formula here. The formula will be 1 minus. It will be same, okay, n by n. This Q1 is nothing but this contingency. This problem only I am considering again below also. So in Q1, what are the total number of classes you have? 4. Total number of values here 9. So at Q1, 4 by 9. 4 by 9. 1 minus, we have this formula, right? In Gini, we have written Gini formula inside this. But for max, we will write max formula inside this, which says that 1 minus. So here we are calculating at Q1. 1 minus max of 3 by 4. This is probability of positive class, probability of negative class. Similarly, for Q1 we have two types, right? Type T and type F. This is type T, this is type F. So type F minus 5 by 9. So again, probability of positive, probability of negative class. And then once you calculate everything, so you have to take max here. Here also you have to take max. You will get error at Q1. Again, error after splitting on Q2. Similar way you can find out. Now, attribute that minimizes the classification error will be selected as the splitting attribute. Now, which has the minimum error here? Q2 has the minimum error. Q1 is 0.778, Q2 is 0.556. So, whichever attribute has minimum classification error, we will consider that as your splitting attribute. Okay. So, this is how you do based on classification error. Now, coming to entropy. Entropy also is again used for calculating. So all these are used for calculating which split is the best split, which node you should, which attribute you should consider for splitting your table into a decision tree. But each formula, has some time based on which formula, whichever concept takes the less time complexity, we can use that. Okay. Now entropy is one. Okay. Here, if you want to calculate, select right attribute for splitting. You can see how you can reach your leaf node quickly. So based on this entropy, you can find out pure split or impure split. Okay. So the formula is this. For entropy, you denote H by S, denote with H by S, and probability of positive class into log of probability of positive class base 2. Remember, this is base 2. While solving problems in calculator, it will be log 10 only, it will be given. You have to divide by log 10, okay? And then probability of negative class into log probability of negative class base 2. So now probability of positive by probability of negative means percentage of positive class by percentage of negative class. It's just something I've written. Okay, now this is your entropy formula. You have to do summation of probability of positive class